So we've learned how to add and subtract complex numbers. We learned how to multiply complex numbers. So what's next? We're now going to learn how to divide complex numbers. So in this, for this section, our example, we want to divide -2 plus I and 1 plus 3I. Right? So even a good rule of thumb, when you have a fraction like this, so essentially when you have a fraction you're dividing, you never want a complex number in the denominator. So just like radicals, we don't want them. So how do we get rid of them? For this one, we're going to multiply it by the complex conjugate. So what is the complex conjugate? So we have A plus BI. Its complex conjugate is A minus BI, and vice versa. So if we're given A minus BI, then the complex conjugate is in the form A plus BI. So in this case, we have 1 plus 3I. So what is its complex conjugate? Its complex conjugate is 1 minus 3I. And keep in mind, whatever we do to the bottom, we have to do the same to the top. Why? Because essentially we would be multiplying this whole fraction by 1, not changing its value. So I'm going to add another step. Okay, keep in mind, so these are in like invisible parentheses. So this is -2 plus I times 1 minus 3I. And on the bottom, we have 1 plus 3I, 1 minus 3I. Okay, so on the top, we're going to use what we learned from section 4, and we're going to multiply it by foiling or any other distribution method you'd like. So -2 times 1, that is -2. And then -2 times -3I is positive 6I. I times 1 is I. And then I times -3I is -3I squared. For the bottom, this is a difference of squares because we're multiplying two conjugates together, or their conjugates together. So what is this? This is going to be 1 squared minus 3I quantity squared. So on the top, we can simplify some things and combine like terms. So -2, we can't do anything with that yet. And we have 6I plus I, that becomes 7I. And then for -3I squared, that I squared is equal to -1. Right. On the bottom, 1 squared is 1. And for 3I squared, that is 3I times 3I, or 3 squared times I squared. So this is minus 9I squared. I'm running out of space, so let's bring our work up here. Right. So up here we have -2 plus 7I. -3 times -1 is positive 3. And then we have 1 minus 9I squared. So I squared is minus 1. -1 times -9, that is positive 9. Right. So maybe in a different color, I'll put this work right here. So -9 times -1, that is positive 9. And that's how we get this value. Right. So now let's combine the like terms. So we can combine -2 and 3. So -2 plus 3, that is 1. And 7I. And then 1 plus 9, that is 10. So if you multiply by the correct conjugate, you should always end up with one term on the bottom. Right, and then like a real value. Right, so we're almost done. So as you can see, we can't simplify this anymore. However, keep in mind, we want our final answer in the form A plus BI. This is not in the form yet. This is just one fraction. So how can I do that? This becomes 1 over 10 plus 7I over 10. And to kind of to see if this is right, so what we know about fractions, if we have A over C plus B over C, since they have a common denominator, we can add the numerator. So this is A plus B over C. So normally we always go from left to right, but we can still, so just like the multiplying property and the division property, we can also go from right to left. So a plus b over c equals a over c plus b over c, which is what we get over here. Now that our answer is in the form a plus bi, we are now done with our solution. Actually, okay, so let me fix something real quick. So I put 7, I kept the 7i on top. Technically though, so you can clearly see the b, it should be, let me just erase this 7. This is 7 over 10i. Right. And giving another little quick check, this still can't be simplified because it's odd over an even. And this is our final answer.